is this channel about? Let's find out. What is the channel about? Okay. Well, the first thing is we challenge the mathematical method, which people confuse and think it's the scientific method. Okay. This mathematical method has nothing at all to do with science, and that's what everybody learns in high school and in college. And so here's the mathematical method in a nutshell. Okay, it's we observe. That's what they say. You have to gawk. That's the first step, gawking. Then you go to explain tentatively. They call that a hypothesis. Okay, they make some kind of prediction. They are all astrologers. Okay, they say predictions are part of the mathematical method. Okay, mathematical method. They do some kind of experiment. We have no idea why they do experiments. Okay. In fact, experiments are a branch of religion. Okay. We don't do experiments in science. And people say, Bill, you're crazy. What do you mean we don't do experiments in science? Yeah, we don't do experiments because experiments, the only purpose of experiments, other than to convince yourself of something, is to persuade others. So we do not do experiments in science. Persuading has to do with convincing the jury, and that's got to do with religion, not with science. Okay, so we do not do experiments. We don't describe, and that's what mathematicians do. Every equation ever invented is only a description. It does not explain anything, and they call those descriptions, those mathematical descriptions, these equations, they call them theories. And no, in science, a theory is an explanation, not a description. And it takes 10 years for a mathematician to understand the difference. Then they invent some kind of technology, some kind of gadget, and they call that a confirmation of the theory. They convince other mathematicians, right, their colleagues. They call that proof, truth, fact, maybe knowledge, any of those. The colleagues, they try to verify the measurement, the equation, all that kind of stuff, and they call that falsification. Okay, it comes from an Austrian who did a lot of falsification, I guess. Then they win a prize. They're granted a prize by their colleagues. It could be a Nobel Prize, a Templeton Prize, a Wolf Prize, whatever. And once you win a prize, now you have certified knowledge. Now you can trounce anybody on earth because you've got, this degree, this higher degree, which is not only a PhD, but now you've been recognized worldwide as an authority on something. And at that point, you can walk the celebrity circuit. Okay, that's more or less, in a nutshell, what the mathematicians do. How do we do it in science? Well, we do it a little differently. This is how we do it in science. First, we define the word science. That's what we do. And they never define the word science. You'll find definitions such as the study of, etc., etc. Now, in science, we don't study. Even a kindergartner studies. Does that mean he's a scientist? So study is the wrong word to use to define science. That's the first one. But then, they never define science in a way that we can use it consistently. So here we define science as rational explanations. Okay? If you don't have a rational explanation, you are not doing science. And that eliminates quantum mechanics, general relativity, string theory, special relativity, and all dissidents out there, such as, the electric universe, flat earthers, and others similar to those. Okay? No, you have to have rational explanation. What is a rational explanation? Or better yet, what is an irrational explanation? Irrational explanation is the movement of concepts. When people start moving love around and they say, look, I moved love, or I moved intelligence, I moved conscience, that's when we have a problem. And the mathematicians, they transfer energy. Energy is a concept, a mathematical concept, undefined one, by the way. But, you can't move a concept, or they move a mass, or they wave the wave, or they warp or bend time, So they're doing all these explanations, and they do them all with concepts, and that's irrational. We don't do philosophy here, very lightly, if anything, ever, but we do physics, and physics begins with objects. You have to have an object in order to do physics. If God Almighty, out there in heaven, I guess, if he erases all matter from the universe, what's happening? What's going on? What's moving? What can you explain? Nothing's happening. So you need objects. That's the first thing you need in physics. And no one in the last 10,000 years, not a single textbook of physics begins by defining what an object is. So that's when we start with a problem. But once you have that, you have to explain causes and mechanisms. That's what physics is about. Here again, we do physics here. And here you have the scientific method. You have a hypothesis, which is not a tentative theory, as the mathematicians think. No, it's the set of assumptions. Okay, you make a set of assumptions, essentially what we call the initial frames of your film, of the theory you're going to explain. So you show the first frame and say, look, this is my starting point, okay? And then you have to point at the objects that are going to be the actors, that are going to be doing the motions, right? Your theory. You have to have the definitions. They have to be ground in stone. It's what most people out there call semantics, word salad, word wizardry, that kind of thing. We call them definitions. And you must have definitions, what we call the foundations of physics. You need to have a certain set of words without which you cannot give a physical interpretation. And then obviously, you have the initial scene, first frame of the film, and we call those a statement of the facts. Then, once you establish that, you can move on to give your explanation, show your film. In other words, tell us the mechanisms and the causes. That's more or less how it works in science, and that's what we do here. And nobody else does that, as far as we know, anywhere on the internet, anywhere on the planet. Okay? So yeah, what we do here is science, physics, and we start with objects and definitions. A lot of people don't like that because they say, oh, Bill, you're doing semantics. You're doing word salad. They don't like it because it destroys their religion. That's why, you got to have sound definitions. Otherwise, you can't get started. We need to know what you mean by your words. In other words, if you're going to tell us your theory. Okay, that's the point. Okay, let's move on here. Give me a second here. Okay, what happened this week? Well, we had some Nobel Prize winners. We had these people. Nobel Prize goes to Trio, who lit up secrets of the atom. This is incredible that they would find secrets of the atom when they don't know what an atom looks like, to begin with. But what did these people do? Well, there was a little article that came out in Ohio because one of these fellows is from Ohio. And they were so proud of him that they put it on the news. They said, the Royal Swedish Academy of Sciences recognizes the scholars for what? For experimental methods that generate attosecond. Attaboy, okay? Pulses of light for the study of electron dynamics in matter. Well, that's technology. That's got nothing to do with science. Okay, so it says the Swedish Academy of Sciences, and they talk about technology. The Nobel Prize Committee said that these fellows, have given humanity new tools for exploring the world of electrons inside atoms and molecules. And have demonstrated a way to create extremely short pulses of light that can be used to measure the rapid processes in which electrons move or change energy. Energy? What the hell is energy? Anyways, all that's technology. And there you see the Nobel Prize is the pinnacle of scientific achievement. No, it's got nothing to do with science. It's got to do with technology. So don't tell me you're doing science. Okay, so yeah, we have a problem with this. And as you can see, they give all these fellows these Nobel Prizes so they can trounce you later on. They can say, look, I've got certified knowledge. What do you have? That kind of thing. Okay, what have all these researchers always proposed? And this shows you the bottom line, how they're different from us, what we do here in this channel. Okay, all these people have always, since the days of the Greeks, okay, all the way to today, both dissidents and mathematicians, the mainstream, the establishment, they have always done the same thing. They've always proposed particles, and more particles. They proposed discrete particles. In other words, their universe is a sandbox. Somehow it's a vibrating sandbox, where all the particles are moving around there in space. Some equate the particles with space, say that space is made of particles. Others say that space contains the particles, as if space were a container of some kind, that has some surface, some edge to it, and the particles are contained within that container. Okay, and this is what it looks like. Okay, you have 100% researchers have always proposed particles. Okay, what do the dissidents call it? They call it ether. They've always called it the ether. A lot of them don't know that what they've been proposing all these years are a bunch of particles. That's what the ether is. And you'll have all these people who call themselves etherists or who propose the ether, and they say, no, Bill, you got it wrong. That's not what the ether is. And again, all I can tell them, don't tell me what it ain't. Tell me what it is. Okay, so don't tell me I'm wrong. Tell me what's right. Okay, and they never come back. They never have been able to tell me what the ether is. Never, not one, huh? So if it's a physical object, if ether is a thing, I want a drawing, I want a picture. I want them to point to a picture on the internet. Nothing less will do. Okay, and don't explain it to me. Don't describe it to me. I want a picture. I want you to point to it. Okay, then it's an object. I don't say, look, let me describe for you a dog, or let me explain to you what a dog is. No. Point to a dog. Then I'll know what a dog is. I know what the word dog refers to. That's how it works. And if you're going to say the ether is a physical object and you're going to use it as a physical object, you're going to vibrate it, you're going to do something with it, you're going to make it flow like a river or whatever, point to it before you move anything. I need it static. I need a snapshot of it, not a movie. Point. Okay? And general relativity has the same problem. They never got rid of the ether. Space-time is the ether, as Stephen Hawking said, famous so-called physicist, mathematical physicist, mathematician. He said, what is space-time? Space-time is a series of events. What's an event? It's a point in space-time. So it's kind of like a circular argument. What is space-time? Space-time is all the events that comprise space-time. What is an event? It's got a set of what they call coordinates, which are really number lines, not coordinates. Okay, and these number lines point to a location where an event happened. If you can reconcile event with a static location. Okay, so we have a problem there too. So there are too many problems with space-time as a proposal to explain, for example, what they're going to explain, which is gravity, okay, warping of space-time. Quantum mechanics, even worse. They talk about particles being at two places at once, etc. But more in the context that I'm talking right now, what they say is that space is made out of all these virtual particles. And these particles, in other words, space is made of it. And what happens? One of these virtual particles comes into the real world so fast that they can't measure it or detect it, but they said it had to come in because it affected, whatever we were doing, so we call it a virtual particle. It just comes in for a split second, goes back to space. And the question you should ask is, when that particle, so-called particle, comes into the real world, does it leave a hole in space behind? So, and then after, 2 hours of them giving you their presentation, they say, oh, by the way, particles ain't particles. Particles are numbers. They only have values. That's all they deal with. So you find out in the end that the so-called particle is not the corpuscle that, for example, Newton was dealing with. Okay, so all this stuff has to be put into proper context. I hope I'm still on. Okay, let me know otherwise. Okay, so what have they ended up with after all these centuries? Okay, especially since the days of Newton, last 400 years, since the so-called scientific revolution. Well, they ended up with this. They ended up with irrational explanations. Okay, they do everything with particles. Okay, and the irrational explanations is because they move concepts around. They transfer energy, they move the mass, they vibrate the field, etc. Black hole, what is a black hole? Well, black hole is allegedly a sun, a star, right, that compressed all the way to a point. What is a point? Point is the center of nothing, because there's nothing there. Matter, according to the great, wizards of mathematics, they say all matter has been crushed out of existence of that star. All of it. There's not a single atom left. What is mass? Mass is the quantity of matter. There's no quantity of matter. There's no matter at all, so we have no mass. But they say we have infinite mass, and with this infinite mathematical concept called mass, they move stars around. They say, look, that star is orbiting a center, and in that center we have a big mass called a black hole. So this is what they ended up with. These are the explanations that we have today. The other one is, Big Bang. The universe had an origin. Yeah, who was it? God, who moved his magic wand, right? Moved his magic wand and created matter. I mean, I'll even concede God. No problem. I have no problem conceding God. I'll concede God. Just tell me how God went from nothing to something. What was the mechanism? How did he do it in his workshop? That's what I want. I want to know the mechanism of how you construct something from nothing. In frame number 1, you have nothing. Frame number 2, immediately, the next frame, I don't care how many frames your movie has, the next frame, you have something. How did God do it? Okay, so of course, what the mathematicians do, they always stop at frame number 2. They never go to frame number 1. They say, look, we don't know. There was a singularity there already. And you say, well, where did the singularity come from? Well, we don't know. That's unscientific. It's an unscientific question because we have no way of testing the hypothesis. That's the answer you get. So yeah, all these people move concepts around. That's why it's all absolute poppycock nonsense, what we have from the mathematical establishment. But they are the scientists of the day. They're recognized as a scientist. No one else is. And so go fight that. Okay, so what is different between what these people do and what we do here? We have a little bit different way of looking at the universe. Okay, and here it is. This is in a nutshell. Okay, this is the bottom line. Okay, mathematical physics and all dissidents, they have particles. They call it the ether. They call it the false vacuum. They have all these names for that. They call it energy, whatever. They say space is filled with all these particles. Sometimes space is the particles. Sometimes it ain't. Okay, what do we have? We have a single thread in all of space. That's all we have. Okay. We call it the rope hypothesis, not because it's a rope, but the rope comes in later. But there's a single thread. If we were to untangle every atom in the universe, this is what we would find. We would find a single thread floating in space. Okay, that's our starting point. So what happens with this thread? Okay, to show you how we're different than all the rest. Well, this is how we envision it. The single closed loop thread. Twined around itself and created all the atoms connected by these ropes, DNA-like ropes, that bind any two atoms in the universe. Every atom in the universe is physically connected because we are all part of this single closed loop thread. This is our universe. Okay, that's our starting point. And I'm not going to go into more detail on that because I've done that in the past. I'm just going to show very quickly how the rope is connected, which is our standard model. That's why we call it the rope hypothesis. Okay, this is the construction. Okay, we have the magnetic thread and the electric thread. We just use to be with convention, right? That's why we use the word electric and magnetic and nothing else. Both threads are exactly the same. They come from the same single thread in the universe. There you have our atom. Okay, so our atom is not a little bead that rolls around the nucleus. Instead, it's a couple threads. One thread goes through the center of the atom. The other one coils around and encapsulates the star that is contained in there. And this is a 2D version. There you see the 3D version on the lower left. Okay, it's essentially a membrane that encapsulates a star. That's what an atom really looks like, according to us. And the red line there, the curved red line, that's the electron shell. You can see the ropes stop at the electron shell, and the two threads fork out. One goes to the center through the center of the atom. The other one coils around and encapsulates the proton star. Okay, so this is our model. Okay, and with this we can explain not only light, which is the torsion of the rope, but we can explain also how the atom is built. In other words, why it does its quantum jump. Okay, it's not the little bead jumping back and forth, but the membrane which expands and contracts. Okay, so we have a totally different model, and we think, and our model, by the way, is really the model that's used by chemistry. Okay, the chemists, they have these balloons, and that's what we say the atom is. On the other hand, the mathematicians, they say it's a little bead that goes back and forth. And the question is, why? What triggers? What compels the little bead to go towards the nucleus and to go out, or prevent it from flying out spontaneously? That's one issue. The other one is when the electron goes close to the proton, which is positive, the electron is negative. Why doesn't it get stuck to the proton? I mean, positive, I thought attracted negative. And here they make it come close to it, but then they have it come back out. So they cheat. That's what they do. They don't have a model. And, of course, they say, well, we don't know what an atom looks like. Hydrogen atom, right? In fact, none of the atoms. They have never seen an atom. Whenever they took a picture, through the SEM, scanning electron microscope, or the atomic force microscope, right, which have abilities to see very well, and I know because I was certified on the SEMs. You can see a lot of stuff there that you cannot see in normal, everyday life. But what do you see? You see balls. Whenever you look at a bunch of atoms, they say, look, we've taken a picture of atoms. Yeah, but what have they taken a picture of? A bunch of balls. You do not see little beads going around painting, orbitals or energy levels or whatever nonsense they call it in quantum mechanics. No, what you see is balls. You see membranes. And that's what the chemists also use. Okay, so we're in line with the chemists and not the so-called mathematical physicists.